everyone, today we're going to talk about what open drain is in I2C. So the I2C protocol includes a bunch of peripherals, and they're all connected on two lines. One is called SCL, one is called SDA, clock and data. Now they're also all connected on VCC and ground, and that's an assumption made by the person who's designing the board. So for now, we'll just draw the connection of all of them to SDA and clock. So when someone is sending data, they alternate the SCL line, the clock, at some sort of rate, and it'll look something like this. On the other hand, in I2C, when you send data, you have to pull the line low on a clock high, depending on how you define it. So this is a clock high edge. It goes from low to high, and so you want to pull SDA low during that clock edge so that people will know that that you are going to start sending data. And then you send your data. It might look something, I don't know what it looked like, but it should look coordinated with the clock edges, and then at the very end you set it back high. So the question is, how do you set it back high, and what does it mean to set data to 1 versus set it to a pull-up? So there's two ways that peripheral 1 sends data. So the first thing it does, as we mentioned before, is that it pulls SDA low. And SDA is kept low, it sends some data, and then you can, and for this you have to write 0 on the GPIO pin. So you set the actual pin to be 0, and by 0 I mean 0 volts. And here it is 3.3 volts. And so you literally set it to be equal to ground. This is 0, this is 3.3. Meanwhile, on this side, on the last side, when you want to end your transfer, you write 1. Or that might be what it seems like, but this is problematic. You should not be writing 1. When you write 1, that means that if someone else wants to come along and say peripheral 2 sends, so if this is set to 3.3, which is the same as writing 1, and then peripheral 2 comes along and they write 0, which sets it to 0, then the SDA line is shared between everyone. So technically you connect a direct wire between 3.3 volts and ground. This is called a short circuit. And this means that you connect 3.3 volts to ground, or 0 volts, with a direct wire. And with the basic circuit equation, V equals IR, or the basic voltage equation, Ohm's law, if you have 3.3 minus 0 volts divided by 0 resistance, then that's going to be infinite amps of current. And that's bad. You might see little sparks fly. So the alternate way to deal with this is open drain. You basically have SDA, you write 0 when you want to start a transmission, and when you're done with the transmission, you set pull-up. And this is not the same as setting to 3.3 volts. So with the pull-up, with writing 3.3 volts, when you write 1, you literally just connect SDA directly to 3.3 volts, maybe through transistors, but it's essentially the same as directly connecting it. When you set, this is what happens when you write 1. When you set pull-up, these are just assumed functions you have in your GPIO library. When you set it to pull-up, you put it at 3.3 volts, but you put a little resistor in here, maybe 10 k ohms, and then you connect it to SDA. And so this is kind of better than what we were doing previously, because right now you have a resistor, and then that connects to 3.3 volts. But then if someone else comes along, if P2 wants to send, then you go set this to 0. You write 0, right? You bring this down. But right now, the circuit looks like this. So you have a connection between 3.3, a resistor, and then ground. And so overall, the SDA line looks like this. This is connected now to ground. Now this is connected to ground. And SDA is being pulled from here. And so the analogy here with the pull-up, let me do it in pink. The analogy here in a pull-up is that the SDA line is directly connected to ground. So the current's going to flow easily here. There's a 10K resistor here, and so this does not flow as freely. So SDA at this point will be read as 0 volts or ground, even though there is a resistor here and it's connected to 3.3. So peripheral 2 wins out, so SDA is just 0 volts. So that's the concept of open drain. I hope this was helpful.